Kia ora Year 11 and 12. This is question 2D from last year's algebra paper, and it's another application of quadratics question. So this is it here. I haven't seen the mark schedule yet because it's not out, but I feel like this is an excellence question. It would be a pretty mean merit question, but we'll see in a couple of weeks. Okay, an equestrian jump has a parabolic arch mounted on a wall. Horses and riders jump through the arch. So we're given a picture of the arch, but we're not given axes on that graph. So we're going to need to put those in. But we'll get to that in a second. So the first thing we've got told is that the arch rises 2.43 meters above the wall. So that means that if this is the wall here, this point up here has a height of 2.43 meters. And then we're given a functional form for the arch. In other words, most of the equation. And the equation is h of x, right, which is just another way of saying y. It's a function, right, and a y is equal to kx times 3.6 minus x. Now, if you're at the very start of Year 11 or 12 and Level 2, you still might be getting used to this notation, but it just means that we take a value of x and out pops a value of y, or h. And here you can think of h standing for the height above the wall. And x meters is the horizontal distance from Q. So I find it easiest to put a set of axes in here to make it into an ordinary old graph. So we're going to draw those in. You're going to do it with a ruler, but I'm going to do it without. Let's see if I can do it there. There's the x-axis, and there's the y-axis. So we can now mark on the information that we've got. So I'm actually going to do a separate bad graph underneath. But first, we should probably finish reading the question. So we've got a rail, AB, that's getting placed above the wall and attached at each end to the arch. And for one competition, that rail is placed 0.5 meters above the wall. And the rail is marked here as AB. So let's draw all of that out and see what we have to figure out. So here are my very badly drawn axes. And here is my parabola. Now we know that this is x equals 0 and this is x equals 3.6. How do I know that? Well, I know it from the form of the equation, which is written in factorized form. And I can read off from that that there's some scale factor that I've still got to work out, but that y will be 0 when x is 0 or when x is 3.6. So we've done this lots in class, but not that many yet in application setting. So we can mark that on. Now we also know that the highest point of the arch is 2.43 meters. And we know by the symmetry of the parabola that that must happen at an x value of 1.8. So the problem is starting to get a little bit easier already. What we can do now, because we know this point, is that we can substitute that in and figure out what the value of k is. And you actually did this in Level 1 excellence questions. There's not anything really too hard about this problem, except that the numbers are not very nice. So substituting in, this is what we get. 2.43, my y value, is equal to k times 1.8 times 3.6 minus 1.8. Okay, and if we wanted to write something there, we don't have to. We probably should though, since 1.8, 2.43 is on the curve. So all we have to do to find k is to manipulate this equation. We've got 2.43 is equal to k times 1.8 times 1.8, giving me k is equal to 2.43 over 1.8 squared, and you know things are going well when you get a lovely round answer of 0.75. So that's our scale factor. Now that means that I can use the whole equation now. We can write h of x, or y, as 0.75x times 3.6 minus x. So that's the first bit of the problem done. Now let's look at what we were asked to find. Well, we've got the arch. We'll draw in the bad arch again, or the bad drawing. There's my bad drawing. And we know that they put a bar for the equestrian competitors to jump over. And that bar in this competition is being placed at a height of, let's change pen, a height of 0.5. So what we have to do is figure out how long that bar is. That just involves one thing. We have to find this point, and we have to find this point, and then we have to work out that gap. So we've got our equation for the function, and we're going to set it equal to 0.5. So we have to solve this. 0.5 is equal to 0.75 x times 3.6 minus x. So that's a quadratic, but we have to expand it to be able to use it. 0.5 is equal to what have we got? 3.6 times 0.75 gives me a nice round 2.7x minus 0.75 x squared. Right, I'm going to subtract this stuff from this side and end up over here. So I get 0.75x squared minus 2.7x. Something's telling me that's not right. Let's see. That's right. That is right. Yeah, good. Plus 0.5 equals 0. Okay, so that's my quadratic. I can solve that in several different ways. I can go to my calculator, or I can practice my quadratic formula. And you know what I'm going to pick. So A is 0.75, B is negative 2.7, and C is 0.5. So x is equal to negative b plus or minus this. Substituting in, this is what we get. Now I'm sorry about background noise if there is any on this video, but it is blowing a gale right outside my study, so it's probably what you can hear. So now we're substituting in, we've got this minus 4 times 0.5 times 0.75, and we're going to divide that by 2a, which is 1.5. So when you work all of those bits out, this is what we get. We get 2.7 plus or minus the square root of 5.79 over 1.5, and that gives me two numbers. I either get 0.196 or 3.404. And when you're doing a problem like this, you can have a look at your graph and see if that makes any sense. And here, that makes absolutely perfect sense, because remember that the ends of the thing were at 0, the arch were at 0 and 3.6. So we know that our value is going to be pretty close to 0 here and pretty close to 3.6. So we should be feeling very confident with that answer, but we haven't finished. We need to find the length of the rail. So rail length is 3.404 minus 0.196, which is 3.208 meters. Make sure you put your units, or what's happened? Or 3.21 meters. Now don't go, because I just want to show you in Desmos how lovely this looks, and we can confirm that we've got that right. Okay, so this is my Desmos graph. There's my equation, and you can see our 2 points here where we've set y equals 0.5, and we've solved for that x value. Okay, and so that gives me my final answer. Whoops, lost it. Wrong question. There it is, 3.21 meters. Thanks for watching. That's all for today. I'll be back with some more videos next weekend.